Welcome. In this lecture, I want to talk about why we prove things. And actually, one of the biggest justifications I have for why I put it, I really expected students to put in a lot of effort to learn to prove things, even if they're going into another field, is how many students I have write to me who go into like programming, who go into a variety of fields and tell me that the most useful thing that they learned in all of university was, coming from how learning to prove things and the structures, the abstract structures and how to work with them. So that's actually the biggest justification I have, but I also think it's important to do this justification of you think you know what's going on until you don't. So here's an example that I like, which is that you start with a circle, and I stick on one dot, and I see, okay, there's like one complementary region, like one region inside of there. So I put a 1 in the middle, like that. And then, again, I take a circle, but now I put 2 dots. And then I draw like a line across connecting them, like a cord. And then I count how many of these complementary regions I have. So here I had 1, and let's just write 1 down here. And here I can count 1, 2, so I have 2. Okay, and then I can keep going. So I draw this again, but this time I put 3 dots. And again, I connect them up by the cords. It's like this, and this, and this. And I count the complementary regions, and I get 1, 2, 3, 4. You may already think you're starting to see a pattern develop, but that pattern is actually going to continue. That you think. So now I put on 4 dots. And I connect all them up by chords. So I do the complete graph on those 4 vertices. They're supposed to be evenly spaced, but I'm a human, so I don't always manage that. And now you can go and count. It's getting longer and longer to count. 1, 2, 3, 4, 5, 6, 7, 8. Okay. And then we continue on. Now I'm going to put on 5 evenly spaced dots. So 1, 2, 3, 4, 5. And I connect them up. So I form the complete graph on 5 vertices. And there's kind of this one you can just do by creating a star. That should work. And then each of them has 4 edges coming out of it, so I did manage to connect each of them to each of the other 4. And then we count. Oh my goodness, a lot of counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. Voila. Okay. So now you really think you know the pattern. And right about when you think you know the pattern, so you might assume with 6 dots, right? So you might assume with 6 dots now, you think you know the pattern, right? So with 6 dots, I think I'm going to get 2, right? To the, this is to the 0th, 2 to the 1st, to the 2nd, to the 3rd, 2 to the 4th. So, but this is 1 dot, right? This is 1 dot, 2 dots, 3 dots, 4 dots, and 5 dots. So you think that you're taking 1 off of the number of dots as the power of 2. So we're thinking we're doing 2 to the 6 minus 1. Okay? Like by this point, you really believe that this is what's going to go on, right? Equals 32 regions. Okay, any reasonable person would think I did 5 examples and I always got this, but it's 30. So it's actually 30. Okay, so that's something to think about, is that a lot of times we think we understand the pattern after, a reasonable amount. There's actually examples going like in like really, really, really big number of samples that like you would first do that would all lead you to believe something. And then all of a sudden it goes wrong. So this is why mathematicians prove things, is to give like solid justification. Also to kind of discover new things are out there, building on each other. And why you should do this also is that it's opening up new ways of thinking and organizing your mind and learning how to, you may almost become sometimes a little impatient when you're like, but that sentence has more than one meaning. You should make sure, like when you're working with mathematical rigor, everything should only have one meaning, it should be precise, it should be solid. And so it also kind of teaches you to think in these ways. Okay, so I hope that was inspirational, and I will see you with the next.